Now we can see how we can separate a solid from a solution. See, it depends on actually the nature of solid, whether it is dissolving in a solvent or not dissolving. See, let's take two examples. First example and case A and case B. Okay, so case A and case B. So here I have dissolved sodium chloride. Here I dissolved calcium carbonate. This is nothing but chalk. Okay, chalk. See, chalk, how it dissolves in water. Okay, see, both case it is water. So how it dissolves in water, you are well familiar. Chalk doesn't dissolve much in water. It's a dissolution in water. It is even less than 1 gram in out of 100 ml of water. Okay. So, the chalk particles, it is actually sparingly soluble. It is somehow undissolved form it will remain. Here actually in the sodium chloride, it is highly dissolved salt. So sodium chloride, it will dissolve properly, and it remain dissolves in a very nice form. Okay. So yeah, in this case, if I am using a filtration, okay, I will come about this particular case once I say about first one. See, in this case, actually, calcium carbonate, since it is undissolved properly, it is not dissolved properly. The easy way you can dissolve is, okay, you can take a beaker. So use a filter paper. This is a filter paper. Okay. So this same solution I pour into here. So this is a filter paper. If you examine microscopically using a microscope, if you examine this, I am considering this filter paper outside. Okay. So this filter paper will contain some porosity. So if I draw here like this, it has some certain amount of pores are there. So through the pores, see these water molecules, it will come through the pores. Okay, but this calcium carbonate being bulky particles, it will try to remain here. It will try to remain here on the filter paper because this calcium carbonate cannot pass through the pores in a filter paper. Okay, so the one way, if the solute is not much soluble in a solvent, one way we can separate out the particles is through filtration. See, this calcium carbonate in this particular case where it is not passing through the filter paper, we call it as a residue. And here the water which is separated out, we call it as a filtrate. Yeah, here our intention may be to separate out, depends actually, like which portion is useful. In some experiments, residue will be useful. Some experiments, filtrate will be the useful part. Another way you can take out the crystals, you can take out the solids from a solution is crystallization. See, crystallization, let's see the example. We will go through an example. See, here actually this containing, this is a water, this contain copper sulfate. Okay. So the copper sulfate, it is a blue color crystal. It is dissolved in uh, this this particular beaker. It is actually more bulky. And the next way is you can just slowly heat it. So in order to take out the copper sulfate from this solution, easy way is you can heat it. See this copper sulfate. So what will happen actually? What happens is this water, it goes out, it evaporates out, like more amount of water it evaporates out, and this solution actually the solution containing copper sulfate, it become more concentrated, more saturated also. Actually, here, like again, if you take it, yeah, this containing more copper sulfate. Okay, and yeah, here this particular solution, it become more concentrated and more saturated. Now, nothing. You doesn't need to do anything. Actually, you can keep this solution for cooling. Keep it for cooling. Before that, what you need to do is, in fact, if you carefully see after cooling itself, you can know there will be some solid particles. It is getting suspended into that. But prior to doing that, you take some copper sulfate into over the microscope. Okay, over the microscope, and if you see very nice carefully, and through the microscope you can see the crystals. It is getting separated, and through the microscope itself you can see the crystals. Now keep it for cooling for some time, and you can see after some time this yeah. You can see sometime the copper sulfate, it is getting slowly, it is getting separated out. So slowly, and you can the solution will become very dark, and it is getting separated out. You just next step is you pour here this solution. You pour this solution, and copper sulfate it got dropped into this filter paper. You can go with the filtration. Okay, so here the water it comes out. This here actually copper sulfate will remain as a residue on filter paper. Take it out, keep for drying. Take it out, keep for drying, and you will get copper sulfate filtrate. Okay, so that is how you can do with the crystallization. Crystallization need to work with certain solutions which in which the solubility of surface solid is more in solution, more in a solvent. Here in copper sulfate is more soluble in water. So you can't simply go with the filtration. Instead, you have to just heat it, make it more concentrated. Like here it is heating, make it more concentrated. Once it is more concentrated, then next step is you can pour it on this filter paper, and you can take out after concentration, after cooling, you can take out. You can go with the filtration. Once then keep the filtrate outside. I mean, like keep the along with the filter paper, you can keep it for drying, and you can take out the crystals. This is how most of the cases crystallization will be working. Of course, there are sometimes certain cases you will be adding some other agents like precipitating agents, say like ammonia. In some cases, acetone. Some cases, propanol. So those agents you will be adding into this mixture in order to precipitate it down. Okay. See, on live example in which this crystallization working is, I don't know how many of you are aware, but certain places where the salt is making, so in those cases actually, like the salt water, actually the sea water, they will take it through. Actually a definitive zone, and they will go for evaporization. After that, what happens is they will go with the crystallization. The salt to be collected via crystallization. Okay. In some cases, see, for example, you take sodium chloride. Best example is sodium chloride. You know the solubility of sodium chloride in water, it is more than 35 gram in 100 ml of water. Okay, almost 36.5 gram sodium chloride will be dissolving in 100 ml of water. That much of high solubility is there with the sodium chloride. So you can't easily separate it out just by boiling and the crystallization. Those things it will not work. So suppose see this beaker containing pure sodium chloride. Okay, pure sodium chloride, and you will boil it. You can do one thing, you can completely boil it, you can boil as much of the amount of water. So what would, and subsequently the whole amount of water it is getting drained off, and all this water it get dried. Okay, I will take here. So after some time, yeah, there will be almost no water. There will be no water, and again you will be heating. What can happen is even this water also it goes away. Here actually you can see the solid sodium chloride particles start to appear. So if the solute is extremely soluble in a solvent, you cannot crystallize, you cannot separate by filtration, you cannot separate by simple crystallization after evaporation. The only way left in front of you is you have to boil out all the solvent. So all the solvent you will evaporate. You can boil it, it will evaporate, and just once it is completely evaporated, you will see dry sodium chloride. You will see the dry sodium chloride and it will be appearing. Okay, so this is how in cases where extreme solubility is there, how we can take out the solid. You see, take one example. When filtrate, actually the separation of solids, it depends on what is the situation. Sometimes filtration will work, sometimes evaporation will work, sometimes crystallization will work, but not all the techniques is going to be suitable in all situations. Consider here in a beaker you are taking sand and also it containing sodium chloride. How are you going to separate it? Because both are solids, you cannot handle it. If you are going to put it into filtrate also, actually both solids it remains in the solution. So one way you can do is you can pour water, because sodium chloride is going to be soluble in water. On the other hand, sand is insoluble in water. So simple, you pour water into this beaker. Now once you pour water, you take out this filtrate. Consider a beaker, use a filter paper, and this sodium chloride, it will pass through the filter paper, because sodium chloride, it contains Na plus and Cl minus, both are ions, right? Actually the size of ions is very small, so it can easily pass through the pores within the filter paper. On the other hand, the sand particle, it will remain here. It will remain on the filter paper. Are you clear? So this is going to happen. Actually, this is going to happen if you are using, if you are using, actually, if you are going into this filtration process. I mean, like if the solids are having different solubility in a particular solvent. On the other hand, you see, consider a beaker containing sugar and sodium chloride. We already know that the sodium chloride is soluble in water. How about sugar? That is also soluble. Sodium chloride and sugar both are highly soluble in water. So, if you pour water, sugar also is going to be soluble in water very nicely. Sodium chloride is also going to be soluble in water very nicely. So, you cannot go with the same stuff over here. You cannot use the same water as the solvent in this case. Instead, we will just work out in which solvent sugar is soluble and the sodium chloride is not soluble, or in which solvent sodium chloride is soluble, not sugar. So any one of them should be soluble in a particular solvent, but insoluble in another solvent. Suppose if you are using a solvent, that either of this, either sugar or sodium chloride should be soluble. Okay. So I used ethanol. Ethanol is going to be, sugar is going to be soluble in soluble. Okay. But sodium chloride is not soluble in insoluble. It is not soluble in ethanol. Okay. So the easy way is, you can pour instead of water, you can pour ethanol here. You can go with the actually, okay, not water but ethanol. You can go with the same filtration process. Same filtration process. What's going to happen is the sugar it will remain. Sugar it will pass through this here, but sodium chloride it will here. It will remain on the filtrate. It will remain as a filtrate. Okay. Sugar it is going to be present in, sorry, not filtrate, right word is residue. Sorry for the mistake. So sodium chloride it will remain as a residue, and the sugar it will remain as a filtrate. Okay. What does this term mean? Give an example. A filtrate, a residue. See, I don't need to repeat the same thing. See, you are having a solution containing chalk, or let it be anything, magnesium carbonate or calcium carbonate. So chalk is, very well that it is not dissolvable in water, and this is actually filter paper. Once you pour this chalk solution here, chalk will remain here, and water it will go through here. So this chalk in this example, it is a residue. Residue is something which is the solid particles which is present on the solution when we are doing a filtration, and the liquid part, this water, or maybe it contains some ions, sodium or chlorine or chloride, or let it be fluoride. So this solution it is called residue and filtrate. Okay. So next question, you have a solution of sugar in water. You want to obtain the sugar from it. Explain why filtering will not work. Which method will you use instead? See. Why the filtering will not work? Because sugar is very much soluble in water. See how you are going to filter. So sugar cannot be filtered because of the high solubility of sugar in water. Which method will you use instead? See, the best method we can use is we can completely dry off the solvent. We can use the evaporating all the solvent. You can completely dry off so that sugar it will remain. In the sugar it will remain, but water will get off. Okay. And third one, describe how do you crystallize potassium nitrate from its aqueous solution. See, potassium nitrate from aqueous solution, how can you crystallize? Easily, you can, the same method, you can boil it. You can boil it so that the solution it will remain concentrated. I don't want to repeat the same thing because we already said it. We can boil it, once we boil it for high temperature, it will get more concentrated, you can keep it for cooling. Once it is cooled, it can be separated out. Potassium nitrate can be separated out. Now, how do you separate salt and sugar? Mention any special safety precaution you would take. Yeah, salt and sugar, I already explained. So you can separate out by pouring ethanol. Okay, because ethanol, sugar is soluble in ethanol, sodium chloride. Sugar is soluble in ethanol. Sodium chloride plus ethanol insoluble. Okay. And what is the precaution you need to take is this ethanol, it is an inflammable solvent, so you should be careful while it is a deal. Okay. And now see if you can think of a way to get a clean sand from a mixture of sand and a little bits of iron wire. Question. See, actually, once upon a time, I was talking with my neighbor. See, I saw he's actually literate. So, while on iron magnet, actually, it was there on the soil. Some soil it was stuck on the magnet. So, surprising to me, he told me this soil it contained some magnetic substances. That is why it is sticking on magnet. Okay, so even though I am educated, even I was not able to get that idea. How, this could be because of that. Even though I observed the same. So, yeah, of course, the same thing you can follow here too. See, consider here, it's a watch glass or let it be petri dishes. So, it contains sand and iron. So you see this, you use an iron magnet. What happens is, all this iron, it goes and stick here. So here actually iron particle it will stick. So what remains is sand. So simple answer is, you say iron magnet.